Hi guys, welcome back to another video. This will be our first chemistry video. Today we will be talking about sig figs, short for significant figures, which are very important for many topics such as unit conversions, stoichiometry, and calculations varying from moles to pH. Anyway, I hope you enjoyed this video and let's get started. So what are sig figs? Sig figs are digits measured within a number that contribute to its precision. They help show how accurate a measurement is. To know which digits are significant, we need to follow specific rules. The rules we need to follow are: non-zero digits are always significant. Zeros between non-zero digits are significant. Leading zeros are not significant. Trailing zeros with a decimal point are significant. Trailing zeros without a decimal point are not significant. Here are a few examples. Let's say you had a decimal number of 1.472. How many sig figs would this have? Well, we would use the first rule, which is all non-zero digits are always significant. This decimal would have 4 sig figs because all digits present are not zeros. Here's a different example, but this time we are not using a decimal. Here's the number 5009. How many significant figures would this have? This has 4 sig figs because the zeros are between the 5 and 9. Even though this number has zeros, we would follow the rule zeros between non-zero digits are significant. One thing we have to keep in mind is that zeros in front of the number are not significant. These are leading zeros. We can treat them as placeholders. The number 0.57 has 2 sig figs. Also, 0.0094 also has 2 sig figs. Now for the last rule. This gets a bit confusing since this rule has a difference with a decimal and without a decimal that both include trailing zeros. Trailing zeros with a decimal point are significant because they indicate measured and known precision in a value. The decimal point tells us that the zeros aren't just placeholders, but that the measurement was precise enough to include them. Trailing zeros without a decimal are not significant because they usually just act as placeholders to show the scale of the number. But a number like 0.050 has 2 sig figs because the leading zero isn't significant, but the 5 and the trailing zero after the decimal are measured. Now, if we wanted to add, subtract, multiply, or divide significant figures, we would need to follow 2 main rules. The first rule is, when adding or subtracting, the result should be shown with the same number of decimal places as the measurement with the fewest decimal places. Let's go through this step by step. First, we line up the numbers by decimal point. Second, perform addition or subtraction. Third, look at the decimal places in each number. Fourth, round the result to the least number of decimal places among the numbers. Let's do an addition and subtraction rule example. Let's say we had decimal numbers of 14.83, 3.76, and 2.1. So the first step is to line up all of the decimal points. So let's do 14.83, 3.76, and 2.1, and let's add a 0. Then we have to perform addition or subtraction. In this case, I will do addition. So then we can find the answer by using mental math or use a calculator. The answer is 20.69. Again, among all of the numbers, we have to round to the least decimal point. So from here, I will write all my decimals again. And write how many decimal places it has. So this has 2. This also has 2. And this has 1. And we want to round to the least decimal place, so we would round 20.69 to 1 decimal place, which equals 20.7. Now for the second rule. The second rule is when multiplying or dividing, the result should have the same number of significant figures as the number with the fewest significant figures. Now let's do an example. So let's say we had decimal numbers 4.56 and 1.4. So again, going step by step, we need to count the amount of significant figures in each number. So this one has 3 sig figs and this one has 2. They both don't have any zeros, so then we would just count the amount of numbers it has. So then, second step, we perform multiplication or division. In this case, I'll do multiplication. So then, if you put this on the calculator, you get 6.384. Keep in mind, we have to round to 2 significant figures since we have to round the final number to the smallest number of significant figures. So, 6.324, should we round this to 3 significant figures or 2? Well, we should round it to 2 significant figures because it's smaller than 3. So our final answer would be 6.4. So that will be the end for today's video. I hope this significant figure video helped you. Stay tuned for more chemistry videos and make sure to subscribe and like. Bye!